Hello my dear students, let us see the problem based on isometric projection. The statement of the problem is like this. A rectangular pyramid of base 40 mm into 25 mm and the height 50 mm is placed centrally on a rectangular slab of 100 mm into 60 mm and height being 20 mm. Draw the isometric projection of the combination of the solid. To start with the problem, I have drawn three different types of lines from a common point. The first line is a 0-degree line, the second line is a 30-degree line, and the third line is at an angle of 45 degrees. The 30-degree line, let us call it as the isometric scale, and the 45-degree line, let me call it as the actual scale. The reason why I have drawn this particular representation is to convert the dimensions from the actual to the iso scale without the help of calculator. Let me mark any convenient point with the help of a protractor. Draw two 30-degree lines on the either side of the point. This is the base of the rectangular slab, 100 mm into 60 mm. The 100 mm, the first dimension I am taking towards the right hand side, and the 60 mm I am taking towards the left hand side, and the height being 20 mm is the vertical height. Now first to start with 100 mm, let me measure 10 centimeters in my normal scale. Students, you just take a compass and extend the needle for 10 centimeters, 10 actual centimeters in your normal scale. Keeping this as the origin, take 10 centimeters on the actual scale, cut a small arc. With the help of the protractor, keep your protractor and draw 90-degree line to the horizontal line. I mean, draw a perpendicular. Now draw the line till it touches the iso scale. This is how you are supposed to convert the actual dimension into the iso dimension. Now let us measure the iso dimension. So this is the actual 10 centimeters or 100 mm in my normal scale. So this is called as the iso 100. If you measure, dear students, if you measure in your compass, the measurement would be somewhere around 81.4 mm or 0.8 centimeters in your normal scale. As I told you the earlier stage, the first dimension, take it towards your right hand side. So let me mark, this marking is the iso 100. Same way, the second dimension is the 60 mm. 60 mm, let me take it towards my left hand side. So measure 6 centimeters in your normal scale, cut it on the actual scale, drop a perpendicular with the help of the protractor. Take the reduced dimension. The reduced dimension will be nothing but iso dimension. So this is actual 60. Now what I am taking is the iso 60. Let me take it towards my left hand side. So I have just drawn the base part of the rectangular slab. Now let me construct the rectangle over here. So with the help of a scale, just draw one more line parallel to the previous line. Or else make sure that the line what you are drawing is once again 30-degree line. Once again, from this line as the reference, so this point as the reference, draw one more parallel line. Now you are getting the base part of the rectangular slab, and height is 20 mm. Now from all the four corners, draw the vertical height. The height is given as 20 mm. So measure 2 centimeters in your normal scale, cut it on the actual scale, drop a perpendicular, measure the iso 20. So cut iso 20, iso 20, iso 20, iso 20 for all vertical height. Now we have got a new four corners over here, the top four corners. Let me join the top four corners. So this is the isometric projection of the rectangular slab of 100 mm into 60 mm base and height being 20 mm. Exactly at the center of this we are supposed to place the rectangular slab. Meanwhile, the unwanted lines or extra lines what we have drawn, let us trim it off. Let us remove it. Meanwhile, mark these two angles as 30 degrees. Exactly at the center of this we are supposed to place the rectangular pyramid of base 40 into 25 mm and height 50 mm. So how to obtain the midpoint over here? So this is the darkened surface, what you can see is the top face of the rectangular slab. Now let me try to obtain the midpoint of it. How to obtain the midpoint of it? So this is the ISO 100 and this is ISO 60. So let me mark ISO 50 here, let me mark ISO 30 here. So ISO 50, let me take approximately, you people go for actual 50, actual 5 centimeters in your normal scale, actual 5 centimeters in your normal scale, cut it on the actual scale, drop a perpendicular. So this will be the ISO 50. So ISO 50, let me cut an arc here. So I got ISO 50. Same way, this is ISO 60 dimension. Let me take the midpoint of it, ISO 30 mm. So ISO 30 mm. So let me take this 3 centimeters in your normal scale, drop a perpendicular here. So this will be ISO 30, cut an arc. Now let me join the two lines here. So parallel to this line, let me draw a line indicating the midline. Let the thickness be very minimum thickness and draw one more line. So this is the midpoint what I have got now. At this midpoint, I want to place a rectangular pyramid of base 40 into 25 mm. As I said in the starting part of my video, the first dimension take it towards your right hand side and the second dimension take it towards the left hand side. And the third dimension will always be the height, or you can also call it as the depth. Now the first dimension is 40 mm. So 40 mm, let me take it towards my right hand side. So 40 mm I will divide it by 2. The reason why I am dividing by 2 is I am having a midpoint here. So I will take 20 on the either sides so that the total dimension will be the 40 mm. So 20 mm, actual 20 already I have taken for the previous case. So already I am having the ISO dimension. So let me keep my compass here. So cut ISO 20 here and ISO 20 on the either sides. Students, now you can visualize the complete dimension is of ISO 40 mm. Same way, let me do it on the left hand side. The dimension is 25 mm. 25 mm divided by 2, take 12.5 centimeter, 12.5 mm in your normal scale, that is 1.2 centimeters in your normal scale. 1.2 centimeters is a very minimum distance, so 1.2 centimeters, cut it on the actual scale, drop a perpendicular, take the ISO distance, keep it on the midpoint, ISO 12.5, ISO 12.5. Now let me construct the base of the rectangular pyramid. So this is the ISO 40 mm. Let me draw a parallel line here. Let me draw one more parallel line here. This as a reference. Let me draw one more line where the arc is there to form the front portion of the rectangular base pyramid, and to this as the reference, let me draw one more parallel line and let me construct the base of the rectangular pyramid. From the midpoint, let me draw the axis. The height of the axis is given as 50 mm. 50 mm is nothing but the ISO 50 mm. So measure ISO 50 mm. Already I have taken ISO 50 mm over here. So this will be the ISO 50 mm. So let me give the height of 50 mm over here. So this will be the ISO 50 mm. We just cut an arc. So now let me join. Let me call this point as a point O. O to A, O to B, O to C and O to D. Let me join it. So this will be O to A, O to B, O to C. Of course, O to D I am not drawing, the reason because it forms the backside portion of the rectangular pyramid and it is not visible. And very important is we are not supposed to name any corners in the isometric projection. So keeping this in the mind, let me go for the orthographic projection towards the side of the board. Let me go for the rectification, the last portion in the isometric drawing. The invisible lines should not be shown here. Let us remove everything. So one by one, coming to the base part of the rectangular slab, this forms the invisible portion. It is not visible. So let us remove it. And the same principle, let us apply it for the base of the rectangular pyramid also. This forms the backside portion of the rectangular pyramid. It is not visible, so let us remove it. Even the midpoints or the midlines is not required, so let us remove it. If you want, you can just retain with the axis line. So this will be your solution. And the last portion is the base rectangle slab is visible up to this junction. So this backside portion is not visible. The reason because there is a pyramid right in front of it. So even this portion is not visible. So remove this portion also. So this will be the solution. Now let us go for the orthographic projection of the same sketch what we are having. Orthographic projections should be as per the actual dimension. Say for an example, 100 mm in the sense it should be the actual 10 centimeters in your normal scale itself. Is it clear? For better visibility, I have just darkened the sketch. So this is your final solution for this particular question. Now let us go for the orthographic projection. Now let us just imagine the observer is standing over here. So here is the observer. So for the observer, this will be the front view, and for the same observer, so this will be the top view. What are all the dimensions for the observer can see in the front and the top view? The first thing is in the front view, the observer can see this particular block. What is the dimension of this block? Here we have taken ISO 100 followed by the ISO 20 mm. As I mentioned you students, there in the orthographic projection that should be in the actual scale. Let me mark any convenient point and let me call it as the mid axis. So let me place my normal scale over here and let me measure 50 on either sides. Actual 50 mm and actual 50 mm. So together this will be 100 mm. Students, please keep in your mind, I am not doing as per the scale. I am just showing you the procedure how to obtain. Clear? Okay. And what is the height? Height is supposed to be 20 mm. So 20 mm is nothing but 2 centimeters in your normal scale. So kindly give a height of 20 mm and construct a small rectangle. Further, followed by what else we can see? We can see this portion of the rectangular pyramid. So what is this portion? So this is nothing but I know this is equal to 40 mm. Clear? Very clearly given, base is equal to 40 mm. So let me keep the same protractor here. So 40 mm. So let me give 40 mm, 20 mm on the either sides. And what is the height of this pyramid? Height of the pyramid, I know it is 50 mm. So let me mark 5 centimeters in my normal scale. So let me join these two lines. So let me mark this height is equal to 50 mm. So this is with respect to the front view. Coming to the top view, when the observer is looking from the top, observer can see this complete rectangle, the base portion. What is this dimension? ISO 100 by ISO 60 mm. Isn't it? So ISO 100 is nothing but the actual 100 here. ISO 60 is nothing but the actual 60 here. So ISO 100 we need not construct once again, already it is constructed. So let me just drop the perpendicular. So I got the 100, that is 10 centimeters in your normal scale. Meanwhile, I just want to finish it by 60 mm. So let me draw a reference line once again. So for the same reference line, let me take 30 mm on the either sides, so that it will be 60 mm. So 30 mm on the either sides. So let me construct the rectangle. Looking from the top, we can see the base of the rectangular pyramid. What is the base of the rectangular pyramid? It is 40 mm cross 25 mm. And since this is the rectangular pyramid, the radial lines are clearly visible. These lines are called as the radial lines. So let me darken from all the points. So from the midpoint to all the 4 corners. And let me measure this dimension as 25 mm. And let me show this dimension as 100 mm. This is the solution for your problem. This is the isometric projection, and this is the orthographic projection, and this is the actual to isometric scale conversion sketch. Hope you like this video. Thanks a lot for watching. We will meet in the next session. Thank you. Have a nice time. Bye.